Friends, welcome to this third talk in the series of AthmaNirbhar Bharat talk series, which is being conducted by Vigyan Bharati. 15th September being the birthday of Sir M. Vishweshwaraya, and 15th October being the birthday of Dr. APJ Abdul Kalam, our former president. Both of these persons have worked tremendously to make India self-reliant. So Vigyan Bharati thought that let this 1 month be celebrated, as during this 1 month we will conduct a series of lectures and invite speakers who have made Bharat AthmaNirbhar. So I have got today's eminent speaker with me, Shri Jitendra Jadhav sir, who is Director of CSIR National Aerospace Laboratories, NAL, Bangalore. Jadhav sir has obtained his B Electronics from University of Pune in 1987 and MS from Computer Engineering Department of Defense Institute of Advanced Technology, DIAT, Pune. He has more than 29 years of experience in design and development of military systems for Army, Navy, Air Force, as well as industrial and railway applications. He has designed, developed, and as well commercialized major systems like fire control systems for tanks, airborne digital optronic pedestal for Nishant, optical fire control systems for Navy, mission and display computer, and weapon control system for light combat aircraft LCA Tejas, as well as tactical mission system for helicopter and digital servo systems for automobiles and railways. So you can get what is the breadth this person has got in terms of design and development. Prior to taking over charge as Director CSIR NL on 27 June 2016, Jadhav sir had worked as outstanding scientist, project director, LCA, and group director in weapon and missile system at Aeronautical Development Agency, ADA, Bangalore, and was instrumental in steering the initial operational clearance of LCA and induction into services. Under his able leadership as Director CSR NAL, the laboratory is making very important contributions towards furthering the Make in India, which is the national mission of Government of India, and spread it to both military and civil aeronautics and aviation sectors, in addition to strategic space, automotive, and societal sectors as well. You must have all heard about Saras, the first 14-seater indigenous aircraft. So Jadhav sir was instrumental in enabling the maiden flight of Saras PT-1N aircraft. He has won many awards and laurels for his significant contributions from ADA and DRDO. He has published more than 20 papers in national and international journals of repute. NAL, which is a CSIR lab, has also developed BiPAP non-invasive ventilator, Swasth Vayu, in barely 36 days during COVID-19. So that indicates how CSIR is working in the country. During his short tenure at CSIR NL, the laboratory has received the Technology Innovation Award 2016 and TechnoFest Award 2016. Jadhav sir has also received Swatantraveer Savarkar Vigyan Puraskar in 2017. So such an eminent personality is here with us today, and he will tell us all about SARAS and the activities their lab is doing to make really Bharat a true AthmaNirbharta. Thank you, sir. And the floor is yours. I welcome you.
Thank you, Mr. Sunilji, Mr. Sastrabuddhaji, and all my Vibha colleagues. Is my slides visible, Mr. Sunil?
Just a moment. Yeah, now they are visible.
Yeah. So it's my privilege to give a lecture on AthmaNirbhar talk for Vidyan Bharti. I am going to tell you how the NL has been established in late 60s. It has established, and then the first foremost thing was making a wind tunnel, and which has been taken by then director Neelakanthan, but he could not finish that, and then Valluri took over, and the first blowdown has happened in 1967. After that, the laboratory was doing on the strategic mission to increase the total life of the MiG-21 and other aircraft, total service life. And also the first supercomputer was developed, India's first supercomputer was developed between 60s and 70s. Then NL started looking at Hansa 3, which is a two-seater trainer, which has been developed in 85s. And then more or less NL started working on fighter aircraft, which is LCA in mid-90s. And then the SARAS, which is a 14-seat passenger aircraft, a light transport aircraft, has been developed in early 2000. Then after in 2016, when I joined, I given three major focuses to the organization. One is in applied research, another is technologies, and another is civil aviation. So in applied research, we are working on aerospace materials like prepreg, thermoplastic composite, coatings, stealth materials, which will go up to 2025. And in civil aviation, from Hansa, we were planning to take it to Hansa NG in 2021. And by 2022, the SARAS will be out as a 19-seater. 2025, we are planning to take it out regional transport aircraft. And by 2030, we will be taking hybrid aircrafts as well as high altitude, long endurance aircraft. This is the future of the NL, and a complete roadmap is there to make our Bharat AthmaNirbhar till 2030. So we have an annual budget about 337 crore, and we have about 1,000 employees, and our lab reserve fund, NL being a laboratory should not talk as a profit, but lab reserve fund, call it as what we have really generated, not only the projects which has obtained from outside, it's a profit out of the project, which has come in 1920 about 63 crore, which is almost more than a 50% of salary. Our lab is certified by ISO 2015, and recently we got a very prestigious aeronautical standard approval 9100D. So this is the future roadmap of their NL, and I will take you through the aircraft programs. So this is the core competence of NL. It is the only unique lab where all the core competence of design, development, and facilities available at one place. We have a structural design, very strong group of aeroelastic and testing, a national facilities. We have a wind tunnel, fatigue test, acoustic test facility. We have a very strong group of failure analysis and accident investigation, and airport instrumentation is one of the important division we are running. We have very strong scientists of computational and experimental aerodynamics, which is required for aircraft design. We have also a division called Aerospace Electronics and System, because nowadays all aircrafts has become a fifth generation and above, and the electronics played a major role. We are the best in composite. We call it as Advanced Composite Division, which is the National Center of Excellence. We have a societal missions of wind energy, meteorological modeling, and all. And also we are have a propulsion for doing engine testing, electromagnetics, and flight mechanics and control and aerospace material. So this is the core competence of NL, and it is the only laboratory in the country where such a core competency design is available at one place. So these are the facilities where we have three major wind tunnels. They are all more 50 years old. We have a compressor facility. We have a fatigue test facility, sled test facilities, high velocity air gun to check the bird impacts. We have simulators, acoustic test facility, and various electromagnetic labs. So this is what is required always to make aircraft design successful, and all the facilities are available at one place. I will just take you through the what all so far NL achieved and how many technologies has gone to the industry before going for the civil aviation program. So one of the important project of the government is light combat aircraft. Everywhere you are seeing LCA Tejas. Tejas is made up of in 1990 the development started, and that time the Dr. Kotari Narayan has decided that it should have a composite technology, and that time there was a technology Daniel, and all the composite parts and technologies which you are seeing are developed by CSIR NL. Also Tejas being a unstable aircraft, it needs a high agility and maneuverability through a fly-by-wire control software that has been designed and developed at NL. And Tejas also having a glass cockpit where head-up display, which you are seeing in the video, is also developed at one of our CSIR lab. I take my pride to say that CSIR has developed that. And a lot more Tejas wind tunnel testing and all has been done at CSIR NL. That the Tejas technologies has been developed during US sanction, and there was a technology Daniel. Tejas is being called as a fourth generation aircraft out of the two major generations, like fly-by-wire control system and software for it, and the carbon fiber technology, which is composite, has been developed by CSIR NL. These technologies are successfully transferred to Tata industry called Tata Advanced Materials Limited, TAML, and Bharat Electronics, and it is in series production. Already 25 sets of this in series production has been produced. There is a large FE saving during development. Now it's looking a meager figure, but in 1995, 250 crore was a bigger figure. And we have done a socio-economic impact, none other than Professor Narasimha, and he has totaled down that it has given about 3167 crore in production, the total socio-economic impact because of these technologies. So this is what the contribution of CSIR NL towards fighter aircraft. We have furthermore contributions, videos are going on. We are working for ISRO satellite and launch vehicles for wind tunnel testing and acoustic testing. Also, we do wind tunnel testing for DRDO missile programs. All missiles goes through our wind tunnel. And we have about 30 crore per year per financial gains from last 50 years, 10 to 30 crore. We also developed 55 HP Wankel engine for Nishant. The video is going on at the right side, which has saved a lot of foreign exchange. We do take now fighter aircraft weapon integration because the Air Force aircraft has become old, and then the weapons are coming new. So all weapon integration, and instead of going to the OEM, we are doing, and there is a substantial FE saving in that sort of programs. I am proud to say that few technologies which I am showing, which is the carbon fiber. You know very well, carbon fiber is a technology, Daniel, to all atomic energy, ISRO, BARC, MOD and all. But we developed a carbon fiber, which is a strength of 4.2 GPa and modulus of 280 GPa. And industry, it has been transferred to the industry. Midani as well as DAE himself is started manufacturing. We made electronic target systems for Army and transferred the technology to BL. Runway visibility, which you be knowing, Drishti, we call it as, about 100 systems has been installed in various Indian Air Force and IMD airports, and the technology is transferred to Central Electronics and Tata Power. When the composite technology we were developing, that time there was the machines also was under sanctions. So autoclave, which is required for composite curing, was indigenously developed by NL, and now about more than 30 autoclaves are there in the country, and they are at various Department of Space, DRDO, IIT's place, and we have transferred this to 4 major technology partners, which has given here as UC, DataSol, KKR, and Vacuum Tech. We also do high-end technical services, which saves a lot of foreign exchange. And recently, we developed a shape memory alloy, which we call it as nickel titanium. So various forms of wires, strips, and rods, and which is very useful for fighter programs as well as Army Navy programs, including fighter aircrafts, and technology is transferred to Midani. Now I will take you through the self-reliance in civil aviation, what NAL programs are. Basically, in civil transport aircraft, there are 5 types of aircraft. One is flying trainer, which is 2 to 4 seater. Cessna 172, which you must have heard, is a monopoly in this category. Then there are commuter aircrafts, which can connect up to 300 kilometer distance of cities, and that is called 19 seater. They are basically less than 19 seater. A Beechcraft 1900 or D was having a monopoly in this. Then there are regional transport aircraft, we call it as 30 to 100 seater. ATR 72, when you travel on the short cities, short distance cities like Banglore to Chennai and all, these sort of aircrafts are working. So they are about 30 to 70 to 90 seaters. Then there are narrow body aircrafts, which call it as A320 and Boeing 737 and all. That is 130 to 180 seat aircrafts. And there are wide body aircrafts up to 380 seats called Boeing 777 and 380. So this is the 5 class of aircrafts is having. And if you see today at the right side, all are imported. So why there is a need of transport aircraft India should have? If you see India, there is a traffic which is about 100 million passenger per year, and Udan connectivity scheme has been introduced in 2016 by Civil Aviation Ministry. Almost 20% increase is there over 2015. And there is a forecast about 300 million passengers by 2022 and 500 million passengers by 2027. So this to tackle, India needs to multiply the capacity to build the aircrafts in next 10 years, narrow body, commuter, regional, almost 5x times. So this is the projection. And today, we do not have aircrafts, and airlines are using narrow body aircraft for regional routes, for even short distance, that is less than 500 kilometer, where load factors are inadequate and they result into the high operating and maintenance costs. Load factors in the case, since aircraft is bigger like 130 seater and all, and the passenger availability is very minimum. So the problem is they cannot use such aircraft for less than 500 kilometers. So this demands a right size aircraft to be deployed. Right side, if you see I made a clusters of airfields in northern cluster, western cluster, eastern cluster, and southern cluster. And if you take a Delhi, so Delhi to Bikaner, Delhi to Gwalior, Delhi to Lucknow, Delhi to Amritsar, these are very short distances. But airlines are afraid to start the aircraft because of they have to use a bigger aircraft. And in India today, about 449 airfields are available today, but only 123 are operational. So you see, to improve the economy of the country, if we can connect all these things, it will be the great this thing for the nation. So in this thing, I will just get you through what are the shortcomings of today's aircraft. So there are 2 categories I mentioned. One is commuter category and one is regional transport category. So commuter category, I have seen the aircraft Beechcraft, Dornier and LET, and regional category Bombardier, ATR 72 and IL-114. All these aircrafts are 20 to 30 years old. If you see, they are developed in 1970s and 80s. So they are very costly to acquire because many of the companies which were supplying the spare parts has already stopped their shop and they are just running to run the fleets. Majority are unpressurized cabins in commuter class. So the aircraft which are shown Dornier, LET are unpressurized, so they cannot work more than 10,000 feet. Expensive to operate because of their age, low cruise speed because of their technology, need extensive maintenance, we already discussed, can operate only from well-equipped airfields, so only as you see in 123 or some airfields are operational, 449 airfields, they are all semi-prepared runways or not well-equipped airfields. And since the technology is 2 decade old, they have high fuel consumption, high maintenance cost, and high mean time to repair. So we had a couple of discussions with operators, what is their needs and demand. So for flying trainers, operators are telling that cost should be low and the trainer should comply to CPL profile as pilot demands has increased. And glass cockpit and long endurance is the today's requirement because the Hansa 3, which you are seeing at right side, is developed in 1990s and it doesn't have a glass cockpit. Commuter and regional aircraft, they are telling that we should able to connect all high altitude airfields like Leh, Pangong, then Shimla or Kulu or Kargil. That sort of airfields, some airfields in the northeast has to be get connected. That is their main requirement. So it needs a pressurized cabin because the airfield itself are at 10,000 feet altitude. Then 19-seat commuter category is acceptable and 70 to 90 seat for regional transport category. The speed should be high because today all aircrafts are about 300 kmph in commuter category and about 500 kmph in about 400 kmph in 70 seat category. 20 to 25% reduction in ownership cost. They want cost low. 15 to 20% reduction in fuel burn. It should have ability to land in ill-equipped airfield and ability to operate from higher altitude airfields. So this majority of these aircrafts which we have shown you, Beechcraft or what you call Dornier and ATR 72, they are not able to operate at Leh, Kargil at that altitude and all. And they should be environmental friendly and reduce maintenance costs. So looking at this operator needs, we have found there is a demand of about 70 to 100 flying trainers, which is Hansa equivalent, 120 to 150 numbers commuter aircraft, which are SARAS equivalent, and 200 and 250 numbers regional transport aircraft, which is of ATR 72 or Bombardier class of aircraft. So taking this into forward, we have revived our Hansa program and we did lot of improvements now in Hansa. We have an advanced turbocharged engine. Also the glass cockpit which you are seeing, a very posh glass cockpit you are seeing at the down. There are 3 displays and engine displays and all communication equipment. The cockpit is looking at par with international standard. There is an improved ingress and egress. We have seen the canopies opening at the front so that pilot can come up. It meets all 6 hours CPL range 900 kilometer, and cost we kept 50 to 60% lower than this thing. So project is already revived in 2016 and we got a sanction from government in August 2018 and we will be completing its certification by March 21. Msme Aerospace is our industrial partner. The partner has been identified right from the design. We already got 10 Hansa letter of intent from the various flying school. The application is flying training for commercial pilot licensing and hobby flying. We have a SARAS PT1N, which has been revived in 2017. You can see the videos where the first flight of Saras PT-1N after the fatal thing in 2009. After 9 years, we revived and made it fly on 24th January 2018. So that is the top video. We participated in Aero India, which is at the bottom. The aircraft has participated in Aero India 2019. 26 flights has been completed, and we have completed all our objectives of whatever listed here about ECS performance, nacelle design and all. And now the data generated will be used for freezing the next product version as per the customer requirement, which we have already discussed. So here is the Saras PT-1N first flight, which was a very, very prestigious flight for us. After 9 years, it has flown. And then we are now taken up a Saras Mark II aircraft, which is 19-seater packs. The Saras PT-1, which has flown and was 14-seater. We have kept low acquisition and operational cost. We'll tell you how it has come. Operatable from ill-equipped and high-altitude airfields was a major important thing which we have already done. Pressurized cabin so that it can fly at 25,000 feet. Glass cockpit, autopilot, low noise and lightweight, and FAR 23 compliance. These are the key features of the Saras Mark II. The status is project is already sanctioned by government, and we will be doing certification by 2015 and production around that. HL Kanpur is a production agency already identified right from the design stage. So this is the second project where the production partner is involved right from the design stage to avoid all production related complexities. I am glad to state that IF has given a firm order of 15 numbers for initial induction, and there is a business potential which we already discussed. So if you see the table below the aircraft, the Saras Mark II is targeted versus Dornier and Beechcraft and all. So it is targeted at max cruise speed of 540 kmph, where Dornier is far, far low, 440, 389, 417 other comparator. Range is quite higher than all the aircrafts. Cabin is pressurized, and specific range per kilometer per kg is higher than the contemporary aircraft. So this is what the target we are going ahead. If you take to meet this target from 14 seat to 19 seat, we did lot of drag reduction and aerodynamic optimization in the aerofoil. We improved the controllability and handling qualities. We use lightweight composite airframe and coating. A 19 packs cabin layout has been done, and advanced avionics and autopilot. So these are the technologies has been put. Just we'll go through the technologies which will make these things happen. We have a digitally controlled turboprop engine, which will give a more specific fuel consumption and lower SFC, and then the fuel consumption will be lower because of the digital controlled turboprop. We have a autopilot. We have open distributed modular avionics and smart AM LCDs and all TCAS and air data computer. We have a maintenance concept that reduce maintenance is called structural health monitoring and the computer for fast troubleshooting. We have ground lean infrastructure, advanced general systems, advanced material, anti-IC coating and other things, and high drag and low drag and high aerodynamic performance, and composite airframe with embedded stealth monitoring. So with this, it is trying to meet the objectives and features which we have shown. So this is the cockpit of the Saras, which is already designed and ready. If you see, there are no dials and very clean cockpit with all glass displays, AM LCD type displays. 4 displays are there, 2 for each pilot, and in between there are all standby displays. Left side is the front view of the cockpit from the outside. These are the 3 cabin layouts has been considered, and they are all quick. They did not need any production engineering. By customer themselves can change the layouts very easily. So that is the concept has followed. So the first First layout at the left side is the troop transport, that is the passenger transport for the 19 seats. If you can count, there are 19 seats, right? Down back side is the baggage, front is the toilet, and this is the entry, and these are the two pilot seats. The VIP cabin is similarly leaving everything front and back same. Internal layout can be changed quickly. And also for the air ambulance, which we call it as CASAVAC purpose also, the internal cabin can be quickly adapted. So that is how the layout has been done, and structural design and engineering has been carried out. So this is the timeline for this SARAS. One is June 19, the project has sanctioned from government, and we have completed configuration freeze and review. We are in preliminary design review, which will be completed in October, November. Then the detailed design review will happen in April, May 2021. And fabrication, equipping, tooling will complete in June 2023. HL Kanpur is the partner, and along with them, we will be completing. And the first flight is planning from June 2023. And in a year or so, it will get certified, because already we are taking a mileage of the earlier flight test. This is the next aircraft which we were talking about, 70 to 90 seater. There are about 1500 kilometer is the range. Its cruise speed is about greater than 500 kmph, and it will be traveling at 25,000 feet altitude, and it has got 1 ton carriage capacity. It has got also unique feature of takeoff and land from unequipped airfield, all-weather operations, emissions lower by 70%, direct operation cost reduction by 20%, and enhanced safety. If you see, there is a cockpit layout, which is also a digital indigenous cockpit. This is the layout for 70 to 90 packs, and this is the structural layout of the aircraft. So ANL has completed the studies, and a lot of activities towards the design has been completed. I have listed here. I don't have to go through it. Everybody knows that wind tunnel test also has been done. And we have submitted feasibility report and DPR to the government, and sanction is awaited. So if you take the summary of what we discussed now, is we have a clear-cut roadmap for the induction of civil aircraft towards AthmaNirbhar Bharat. The first is we are at 2020, and in 2021, Hansa NG production will start. Industrial partner is already identified, Mesco Aerospace, and 10 numbers of letter of intent are already available. By 2025, HL Kanpur is identified as the industrial partner. IF has already given 15 numbers order, and 2025 Mark II will start. These two projects are shown green because they are sanctioned project. And if government sanctions immediately the project, by 2028, we can start production of 70 to 90 seater, and we are awaiting the sanction from the government. So this is what the thing. We feel that there will be tangible and intangible benefits to the society. Tangible is the amount of FE saving will be in the tune of thousands of crore. And intangible is there is a employment generation more than 20,000, because Hansa will be done at at Madhya Pradesh, and Saras will be done at Kanpur, and also there will be one more industrial partner. If the number of the quantity and the demand increases, we will make one more private partner into that. It will be a major trust to Made in India, with promotional of several MSMEs, skill development, technologies development, infrastructure and ecosystem will get developed, and we can do entry into international civil aircraft market. It will be a unique example of AthmaNirbhar Bharat for India as well as export. I just wanted to touch to COVID-19 initiatives of CSIR-NL, and being an aerospace laboratory, we have developed a non-invasive BiPAP ventilator. As Mr. Sunilji says, we have done it in 36 days. It's a non-invasive ventilator, a very cost-effective, easy to use, in makeshift hospital, wards and dispensary. It doesn't need ICU. We have certified it by NABL accredited lab for safety, calibration and performance. 6 industries has taken the transfer: Bharat Forge, Paras Defense System, ACL Data. So we have completed clinical trials at Jubilee Hospital, and DGHS has given a provisional conditional clearance to treat mild and moderate patients, but they want some more data. So some more evaluation at Government Medical College, Mysore, Command Hospital, Bangalore, and AIMS Bhopal is being initiated for type certification by DGHS. Within a month time, I think we'll get a full-fledged approval, and these provisional conditions will go. And we have a production capacity with all the vendors about 350 ventilators per week. So this ventilator has gone through the endurance test for continuous 150 hours, which is the mandatory requirement. Beta trials on 5 normal patients has been done, and 1 on sleep apnea. This is one of the trial going on in our hospital for 64 hours. And then we started clinical trials. And today about 100 numbers of COVID-19 patients has been treated with this machine. It has got a unique mode which is not available in the other machines, called spontaneous mode. And also, if you see, here is a HEPA T filter where when patient exhale, the aerosol should not go to the other outside. That was the requirement, and that is a unique T filter joint has been developed in a 3D printing mode. We also developed coverall with protective shoe cover, and that has been done in 7 days. More than 1 lakh has been produced and supplied to various things. And we have done along with this partner. This is basically an indigenous fabric and seam sealing tape. All other coverall seam sealing tape is imported, but we developed on our own. And these are the certificates of this coverall. Thank you very much. I have finished.
Thank you very much, sir. It was a very nice and crisp presentation of the journey that you have taken us through. And a few of the questions that we have is one of the question is the engine of these aircraft, Saras, is also designed in India, or the other systems
Engine
only
is
are
not designed in India because engine, we have a lot of technology gaps in India. So engine of all the aircrafts are imported.
Okay, okay. And I would like to elaborate more on your when the Saras was test flight was done, because of the previous bad experience.
Yeah.
There must have been a lot of tension, and
Yeah.
so can you please
See,
elaborate
when
some more
I took over as a director NL, there was total loss of confidence in the scientist, I found. And the Saras was taken in the corner of one of the hangar because scientists were not confident after such accident, even though DGC has given a green chit that it's not a design fault. Then I went into one by one. Then I found that there are a lot more. The outcome of this DGCA report of accident investigation says there are some modifications required to fly. And then we started taking that modifications like rudder power. In case of one engine fail, the rudder power was not adequate. So first modification done was the rudder power. Then lot of forces of control surfaces onto the pilot were very high. So that has been reduced drastically within the certification authority acceptance. And then lot more other things like stall warning system, and then autopilot to the partial thing also has been improved. And then all the systems which since 9 years the aircraft has not flown, needs calibration, needs complete overhauling, that has been done. And the major concern was the airframe, because the airframe, if you keep so many years in your garage, you don't know what happens. So the complete inspection, we call it as boroscopic inspection. So the complete airframe inspection has been carried out, and also from internal, external, moving parts, everything. Then we went to the certification agency, and I must be thankful to Semilac and DJQA, who has allowed us to take our documents and come and all. Then slowly certification agency got confidence. Then we went to Air Force. We have a ST establishment. We have explained then this is how the aircraft has been now brought to this shape. And then they were also very, very cooperative. They understood that everything has been done professionally. And then, of course, there is a flight readiness review board which goes through the whole reviews. So we had a number of meetings of flight readiness review board, and then first engine ground run has been done almost in April 2017. After engine ground run, enormous engine ground run, issues of this, that, pilot has to get confidence, new crew. After that, we have another FRRB to do low speed taxi. So that has been done, I think, in August 17. Then we conducted about 30-40 low speed taxis. Then the complete whole stakeholders got a confidence that this aircraft done. Then again one more FRRB for high speed taxi. Then we conducted about 10 high speed taxi. And then the D date has come, and FRRB, by seeing the data and analysis of all these trials, and the pilot become very confident. One important thing is there was no simulator earlier. Parallelly, we developed a high fidelity simulator where pilot has got more confidence that simulator and HSTT, LSTT results are matching, and then flight has happened. But as you said, first day was very, very tense to all of us, but when it landed, we have already left our breath. Otherwise, we were just holding our breaths. That's all. Thank you very much.
Okay, one more question coming from Dr. Bhushan Joshi. First of all, congratulations to NAL for developing this. His question is, what efforts are being taken to prepare industry, that is the MSME sector, for manufacturing of various aircraft subsystems or sensors, actuators for production and maintenance?
Actually, very good question. Since light combat aircraft has now in the series production state, so a lot of ecosystem which is developed by light combat aircraft and ALH in MSMEs. If you say today, we call it as USMS, that is Universal System, Mechanical System Computer. Then we call it as Mission Computer. We call it as Actuators for small thing. All this ecosystem has been done in light combat aircraft with MSMEs only. There are all small people only are supplying these parts. And what we have adopted design policy is, let's not duplicate the efforts. Let's use as much as possible which has done in light combat aircraft. We may need small re-engineering because fighter aircraft is different and civil aircraft is different. So we are only going with re-engineering of the thing. But whatever indigenization has happened in ALH and light combat aircraft, everything like actuators and computers and brakes and wheels or hydraulic system, landing gear, everything is done with the same MSMEs or in some cases, some bigger industries, and that is the policies adopted.
Can you highlight the safety features of Indian aircrafts against those of international players?
Actually, Indian aircrafts and international players safety features are same because we comply to the FAR 23 passenger aircrafts. Okay, so FAR 23 is common across the world. Okay. Only thing is we added a few features which they don't have. Like their aircrafts, if Russian makes the aircraft, they make to operate only at high altitude. Means at that particular minus temperature, but they forget plus temperature. Okay. Europeans forget plus temperature and lesser minus temperature. But our country is totally different. Our country is having minus, plus, also high altitude airfields and all. So that particular thing to make aircraft director operational cost for this sort of very varied terrain, I can say. We have a sea level, we have a layer at 3 kilometer, we have northeast, we have everything, okay, and we have a temperatures. In summer, Rajasthan goes to 50 degree. In summer, Leh goes to 50 degree. In winter, same layer goes up to minus 30 degree. So this is the thing. So we have, that is the challenge basically. But as far as international aircraft certification standard is same, but the design is different to take care of this operational requirements. Coming to safety requirements, there are international standard doesn't say you put autopilot, okay, and we have put autopilot into the aircraft. It's a semi operated autopilot, but we are allowed it to go up to cat to landing. That means if you are at 100 if you are at 100 meter and if you have 5,000 feet visibility, you can come up to that and then pilot can take a control for landing. So we have added an autopilot into that. So what happens is, even though in case the control system pilot found high workload and all, the autopilot will aid it. So that sort of safeties and other things has been added.
One question is there from Vikas Saxena. This is regarding, are we developing any software to design and test aircraft? So perhaps he wants to ask, the simulation softwares you are using indigenously, or they are also whatever are commercially available?
Now, I can answer this question in two ways. Before aircraft gets materialized, we have a high fidelity simulators, okay, which are totally indigenously designed and developed in the country. And NL is the pioneer in high fidelity simulation. In this high fidelity simulation, when our design is completed, we put that 6 degree of freedom model of aircraft and all other models like autopilot or flight control, actuators, all models, engine model will be integrated. And the pilot comes in the simulator and flies the aircraft, okay, with these models. So he get a feel of the controls and various system and all. Now the second stage comes where all these models are actually physically realized through the hardware. We call it as Iron Bird. So Iron Bird is an exact replica of the aircraft by all length and everything. Only thing is it doesn't have shell. So removing shell, everything will be there, and that will be integrated all the subsystems, you name it, FCS, hydraulic, electrical, USCA, what you call redundancy, everything will be integrated at Iron Bird. And again, pilot comes there and fly. So he get a complete feel, and including load factors also will be given on to the control actuators. So these test facilities and these testers are totally indigenously designed and developed.
There is a great piece of information, because this indicates the capability of our scientists and engineers, that they can do and make India self-reliant. One more question is not actually related to aero, but in general it is related to the transport. And the question is from Sohail Sheikh. Please share your thoughts on Hyperloop and what can be done for India to start developing such transportation systems. So I don't know, perhaps you may choose to answer, or you may choose to.
Hyperloop transportation system at what height he is expecting? 70,000 feet and all?
No, no, no. The normal civil road transport being replaced by Hyperloop, that's what the technology.
I am sorry to say I cannot.
Yeah, this
Make
is
it.
not a very relevant question. One question which I think I have one last question. That is the what can be the in terms of cost? I mean, indigenously we have developed Saras. That is a very great achievement. But cost-wise, how is it as compared to the competitors?
Yeah, very important question because today, if you see the contemporary aircrafts of pressurized, they are costing about 65 to uh, 65 crores around, based on their whatever inside, what type of luxurious things and all. We are planning to keep cost about 15% lower than the contemporary aircraft.
That is a really a great achievement because we have been, as you have shown, that there are some extra features in Saras as against the competitors, and we are keeping the cost low as well. So
Yeah.
I think it will give a real boost to Indian aviation industry when this gets fully commercialized and in the market, and then we can I can see a day when we are just like we have been now exporting cars to South Africa and other countries. We will also be exporting all the aircrafts, the design of which will be proudly we can say that one day will NAL will export this design and the aircrafts to other countries, which will be a really proud day for us. So, sir, I thank you very much again for
Thank you.
giving
Thank you.
time and participating in this AthmaNirbhar Bharat Talk series. For the viewers, I would like to say that every Saturday, Sunday, that is next two Saturday, Sundays, we are still having very interesting talks. So keep on viewing this Vigyan Bharati channel and you will find the notifications and spread the word so that we can bring in and reach that what these people are doing wonderful jobs, our scientists and engineers, let it be known to all the Bharat. So dhanyavad sir once again.
Dhanyavad, Dhanyavad. Thank you, Sunilji.
Thank
Thanks.
you. Yeah,
Convey my regards to Jayant also.
definitely sir, definitely.
Thank you. Thank you.
Meeting him virtually now.